Thanks so much, everyone, for joining us today. My name is Sarah De Levesque, and I'm Managing Director of Regenerative Food Systems Investment. It's such a pleasure to have you here. For those of you who are not familiar with our community or are new to our community, Regenerative Food Systems Investment, or RFSI, launched in 2019 to address the lack of capital flowing into regenerative food and agriculture systems. Our mission is to create opportunities for investors, funders, and activators to learn more about investing in a new food system and to connect funders with opportunities for investment. Our annual convening, the RFSI Forum, takes place each year in the fall. We just wrapped up our first in-person event in 2 years in Oakland at the end of September, and it was such a blast to be together in person. RFSI also serves the sector with virtual events, a newsletter, a directory, and webinars like the one we are here for today. You can learn more about RFSI at rfsi-forum.com. And so before we get started today, I do need to walk through the obligatory webinar logistics. Thank you all for being here today. You'll notice that we are not in webinar form. We are in a meeting, which means we can all see each other and we can interact a little bit more. So all chats today will be submitted through the chat function. So, excuse me, all questions today will be submitted through the chat function that you can access by clicking on the chat function at the bottom of your toolbar on your Zoom screen. We also, if you have any technical difficulties, you can reach our team via that chat function as well. You can also use the chat to share resources or ideas with other people. We love interaction, so please feel free to use that liberally. We also love to know who's joining us on these calls. So if you want to include your company name or your farm name in your name on the Zoom screen, you can go ahead and do that by clicking on the 3 dots that are in the upper right-hand corner of your Zoom picture. And when you click on that, it has an option for renaming. And if you click on rename, you can rename. So you can make yourself Sarah De Levesque -RFSI or something that's more appropriate for your picture. Okay, so with that, we will move on to the main program. Today, we are so pleased to introduce an important discussion all around soil health innovation, brought to you by Sound Agriculture, an innovative firm offering solutions to growers seeking to build sustainability and resilience while improving farm finances. Today, the Sound Ag team will walk through a robust conversation, but again, we absolutely want you to be involved too. So please do submit your questions in the chat as we move along. And then we'll make sure that the team addresses those in the Q&A time at the end. With that, it gives me great pleasure to pass things over to Travis Bayer, who is co-founder and Chief Technology Officer at Sound Ag. Welcome, Travis.
All right, thank you, Sarah. And thanks everyone for being on the call today. So good morning, afternoon, or evening, wherever you are. So what we want to do is have a conversation and really talk about how you can activate soil biology to have better outcomes on the farm. And that's in terms of sustainability, profitability, as well as being good for the environment. So what we're going to do here is kind of break this up into 3 parts. What I'm going to do is just give you a quick introduction to how we think about the soil microbiome and how that is part of a healthy on-farm ecosystem. Then I'm going to pass to my colleague, Jeff, our Director of Sales Agronomy here, who is going to tell you about the sort of real world or more practical implications of that with nutrient efficiency on the farm. And then Jeff is going to have a conversation with Trey Hill, grower out in Maryland, who is going to talk about how this works literally on the farm, what this looks like in action. So first, let me give you just a little bit of introduction to Sound Agriculture as a company. We are a life science company that's really focused on sustainability in agriculture. And you're probably going to hear maybe 3 or 4 different definitions of sustainability from myself, from Jeff, and from Trey. But we'll get into that as we have the conversation. Broadly, what we're trying to do is create products and solutions for growers to grow food more sustainably. So basically to improve the health and ecosystem of their farm, as well as improve the profitability of their farm. So we really see that the whole food and ag system needs to become more resilient and more agile as we face a lot of challenges in the environment today, including climate change, including changing consumer preferences, and so on. So this is really what we're all about with our mission and vision. Just to do some quick intros here on who you're going to be hearing from. So I'll give you a quick bio of myself and then pass it on to Jeff. But I'm the Chief Technology Officer here at Sound. I lead our research team. I'm a scientist by training. Spent a lot of my career in the field of biochemistry and molecular biology. And prior to joining Sound, I was a professor of biochemistry at Oxford and Imperial College London before that. So I really come from the molecular side of the world. Spent a lot of my career thinking about how plants and microbes interact at the molecular level. So looking forward to sharing some of that perspective with you today. I'll pass it on to Jeff now to do a quick intro.
Yeah, thanks, Travis. So my name is Jeff Divan, director of the agronomy team here at Sound Ag. Home for me is North Central Iowa, farm a few thousand acres of row crops here as well. Have spent a lot of my time in different ag technologies, so some digital solutions, and really just always kind of applying and bringing them to the farm. So I'll offer some insights today on kind of the applications of some of these different strategies and what Travis presents. So I will hand it off to Trey.
Yeah, I'm a large-scale corn, wheat, and soybean farmer in Maryland, trying to integrate different practices to kind of take what I'm doing and make it better. So we farm completely different than we did 10 years ago in terms of tillage, application, and instituting technological advancements. And we're kind of looking to see where we'll be in 10 years, which hopefully will look completely different than what we're doing now. But we're doing the best we can given the nature of our business.
All right, thank you, Trey and Jeff. Okay, so let's dive in. So I'm just going to spend a few slides and a few minutes here talking about the soil microbiome. And to kind of set this up, one of the ways that we think about sustainability, that I think about sustainability on the farm, is really thinking about efficiency. So one of the issues on farm that we really focused on early on in the life of the company and have continued to work on and are getting more and more excited about as we see technology and products make it to the market is really around fertilizer. So you're going to hear fertilizer talked about a bit today. So I don't want to set up fertilizer as the villain in this story because the use of synthetic fertilizers really has enabled tremendous productivity on the farm over the past century or so. And without the advent of synthetic fertilizers, we would probably have a lot more hunger and starvation in the world. But where we stand today, we would really like to get to a place where we can use fertilizer to boost productivity, but do it in a more efficient way. And what we know from the farm is that application of fertilizer is pretty inefficient. A lot of the nitrogen fertilizer you put down ends up leaching or volatilizing to the environment. So only a fraction of what we actually put on the ground makes it into the plant. We know the same thing happens with phosphorus. A lot of the phosphorus you put down as fertilizer gets locked up in the soil, basically gets bound in an insoluble form in the soil and doesn't make it into the plant. And so what that means is two things. One, from an economic impact, a lot of what the grower is investing in terms of fertilizer isn't making it into the crop or into the harvest at the end of the day. And the other is there's some negative externalities around that. So a lot of, especially on the nitrogen side, a lot of that lost nitrogen ends up as air pollution, water pollution. At the end of the day, those are negative outcomes. So this is kind of where we start from, thinking about, okay, adding fertilizer is inefficient. And that really is sort of reflective of a broader trend in conventional agricultural systems where we have pretty high yields. It's really intensive input systems, but we also have fairly high outputs and high losses. And so this is a system that has sort of sustained us for the past century or so, where we're getting high crop yields, but there's a pretty negative impact in terms of air and water pollution, carbon emissions, et cetera. And one of the ways we look at this at Sound is that, in this conventional system, you're really thinking about the soil as a substrate only. You're not really getting a lot of soil biological or chemical processes that help you be more efficient. So there's another aspect of this as well, and going back to fertilizer, especially around the inefficiencies of fertilizer. If you've looked at fertilizer prices lately, you've just seen this massive increase in prices over the past couple of months. They've gone up several fold. And this might have actually gone up since we've started talking here. But what this means is that the sustainability impact of fertilizer is certainly a big deal, but the economic impact of fertilizer inefficiency is becoming a larger and larger bottom line issue for growers. So this is one of the sort of things that we're interested in helping growers solve, is these massive fertilizer price increases. Okay, so let's talk about what we're trying to do at Sound. So if you go back to the conventional agriculture system on the left, that's really resource intensive. You have high yields, but you also have these negative externalities and negative impacts. What we like to do is move to a system on the left here that's more regenerative, where you have robust soil processes, so biological processes, chemical processes, that mean that the resources that we put down are used more efficiently. So you still have high yield, high output from the system, but you have lower losses. You don't have as much runoff. You don't have as much air pollution. And overall, you're able to use that dollar you spent on fertilizer in a more efficient way. So the way we think about this is really treating the soil biodiversity that's there on the farm as an asset, and thinking about ways we can unlock that soil biology asset. So let's spend just a minute talking about soil microbes. So I get really excited about this as a guy who comes from a molecular and microbial point of view. But if you think about walking across an acre of soil on the farm, there's a lot of biodiversity under your feet. So in a handful of soil or a teaspoon of soil, there's literally billions of different species. And these are bacteria, these are fungal species, these are even protozoa, sort of small animals like nematodes. So they do a lot of things in the soil. They help basically decompose biomass and organic matter that's there and make those nutrients available to the plant. And they can also do really cool things like convert atmospheric nitrogen into a plant available form. So this is some pretty amazing chemistry if you think about it. They're actually taking what's the massive reservoir of nitrogen in the air and making that into a form that the plant can actually access. Not to mention other aspects like soil, like building soil structure and providing more surface area for the roots to access nutrients. So soil, again, it's a rich living thing, and there's a ton of diversity down there. So one of the things that is also really cool about the soil microbial community is that plants and microbes are constantly communicating and effectively bartering or trading nutrients as part of the natural symbiosis. So this is it's a little bit of an esoteric concept to think about plants and microbes talking to each other, but the way that they do this is through small natural chemical signals. So what typically happens with a symbiotic bacteria is that as your crop starts to grow in the ground, the plant will send out a signal basically into the soil. And what that does is activates or recruits microbes. So the microbes have evolved to detect that chemical and to use that to know that a host plant or a symbiotic plant is nearby. What then happens after the microbes and plants have established this relationship is they're typically trading nutrients. So one of the classic ones here is a group of microbes called arbuscular mycorrhizae will actually give the plant phosphorus in exchange for sugars. So this really is an ecosystem in the soil where both sides of the balance sheet, the plant and the microbe, get something from the other partner. So this is really a system of communication and symbiosis that can tend to get lost and can tend to get degraded in modern agricultural systems. So one of the things that happens when you add a lot of fertilizer, for example, is the symbiotic relationships break down. So one of the things we're really interested in doing at Sound is figuring out how can we jumpstart these relationships again? How can we basically turn back on this natural symbiosis? Because if we can do that, then we can actually get more nutrition from the soil and from these natural ecosystem processes that we have basically turned off by our conventional practices. So that leads me to sort of the last slide of my section here, which is this is where we start from a scientific point of view. What we're trying to do is figure out what are these molecules that plants and microbes use to talk to each other, and then how can we tap into that? How can we leverage that understanding and actually create products that have those natural signaling molecules in them to jumpstart the process. So what we're trying to really do is mimic this communication between plant and microbe, get in the middle of it and kick it off and get it started again. So what our discovery platform really looks like is a bit like drug discovery, where we're looking at multiple different types of chemistry. We're screening those against microbes, we're screening those against plants and seeing which ones work best, and then moving those into the field and seeing, do these actually create real world impacts? So we have a couple of different product focus areas, and you can see they're all really focused around improved sustainability and improved productivity. But the one we're going to talk the most about today is really products like this that can create clean alternatives to nitrogen and phosphorus fertilizer. Okay, with that, I'll pass it over to Jeff to tell you about what this looks like as we move towards the farm.
Perfect. Thanks, Travis. Yeah, so excited to jump into this section, and really look at some of the applications and strategies that we can use on the farm, kind of where the rubber meets the road. I think we could all talk about the ideas, that they're good, the direction is good, but how do we actually do it? And some of that will be through products here at Sound. Some of that will just be strategies that farmers can use and getting towards that direction in general. So I know it's a topic that I get excited about, Trey gets excited about. So hopefully this is kind of a fun little section here. So go ahead and advance, Travis. So the first thing around a healthy soil, and I know Travis kind of alluded to this, is soil is not just a substrate. It's not just a place to grow a crop. It can very much be a contributor to that system and a contributor to the overall success of growing that crop. But we have to partner with that soil and really make sure that we're striking a balance with it in our use of that area and of that ecosystem. So when we work for a soil, and what I mean is entering into crops and not just letting that soil sustain itself, we really want to make sure that we follow a concept called Liebig's Law of the Minimum. So been around for a very, very long time. And what this really is highlighting is the fact that we can't be, just a master of one nutrient and not a jack of all trades when it comes to soil health. So kind of the opposite that expression gets used in kind of normal speak, but we want to make sure that we can't, that we're not limiting our yield from our most limited nutrients. So striking a balance, and that's not just nutrients. That is what we're doing with soil structure, with water, with light, with every single part that's part of that cropping system. We want to make sure that we strike a balance. When we do that, we create a really, really resilient soil, and resilient soils can help sustain resilient crops. So they make us able to use more of the nutrients that we apply. They allow us to better use water that we apply, increase our yields, and decrease our inputs. So really, we want to make sure that we're working and managing our fields to allow them to benefit us back. All right, next slide. So I kind of just divided this up into 4 strategies, right? I didn't want to just be kind of top down and not have anything directional. So I put into 4 buckets here, areas that we can think about restoring that balance and making sure that we are allowing that soil to support us back when we plant a crop. So number 1 is just soil testing, right? It's hard to know what we need to place on a field if we don't know what's there to begin with. So this is nothing new, but we want to just make sure that we know where we're starting. That's our baseline, and then we can develop strategies to move forward from there. The second is just to minimize tillage. So a soil is intended to exist in its natural state, right? There are many layers, there are many systems, connections, as Travis alluded to, in place, and they all develop their structure based on how they lie. So anytime we come in there and do tillage, we are inverting some of these layers, we're breaking some of these connections. We want to make sure that we leave as much of that system in place as possible. The next bucket would be efficient nutrient application. So a lot of you have heard of the 4 R's: right time, right source, right rate, right place. It sounds a little redundant to talk about, but it is very, very critical in optimizing the spend on fertilizer and just making sure that we're actually getting those nutrients into our plant and into the grain, ultimately, if that's where we receive our revenue from. And then the last is just to maintain those diverse and living roots. So cover crops is obviously a big target here, crop rotation as well, intercropping. Anytime we have a diversity of plants, we are attracting a diversity of soil microbes and contributing to soil health. So the more the merrier when it comes to living organisms within that soil. All right, next slide. So we'll kind of dig into each one of these here individually. I want to start with no-till. So one of the interesting things about tillage, and just as we think of organic matter, creating organic matter really happens from the top down. So as we have crop residue, as we have some of those interactions with weather and breakdown of that residue, that happens from the top down. So in order to really build organic matter, which can contribute nutrients and all kind of facets of soil health, we want to leave that, as minimally disturbed as possible. When we do, we're then allowing things like soil structure to go to work for us. So we get more water that we apply into the soil when we have, those nice channels that earthworms create and that good soil structure creates, even down to the very, very small, tiny exudates of roots that can still help to build some soil structure and create some pores. When we run through that with tillage, we're really kind of inverting some of those and making those connections that happen to break down some of that residue and turn it into available nutrients. We're distancing them from where they need to be to get their job done. So no different than, I think if you think about moldboard plowing to bury residue and create organic matter, that couldn't be further from how we actually get that to happen from the top down by leaving some of this residue and soil structure in place. So when we leave it, we reduce erosion, we increase air in the soil. So we want to keep that perfect balance of all things that soil needs and really impact it the least amount possible. Not to mention when we make that tillage pass, we're releasing a whole bunch of CO2 and kind of undoing all those benefits of storing carbon in the soil as soon as we expose that to the air. So that's the first thing. I know we have to do maybe a little tillage in some areas, specifically where I farm here in northern Iowa. That soil will stay cold through the end of May if you don't do a little something. So strip till is also definitely an option as we think about maybe just warming up where that seed lies and not doing just full width tillage. All right, next slide. Okay, so another one then is cover crops. So that's actually a picture. That's my view when I'm planting here in northern Iowa, looking out the front of the tractor. So planting green, put cereal rye, then strip till behind that. So I'm getting the benefits of that warm soil, a nice seed bed, and keeping some of those living roots in the soil. Very unconventional for this part of the world, and Trey will dig into that more too as we talk later. But having a cover crop and a living root is doing a few different things for us. So if it's a legume, it can actually fix nitrogen. So we can be creating and cranking up that bacteria that's fixing atmospheric nitrogen, adding that into our system in a period of time where otherwise we're probably not, using that soil for much in a post-crop kind of or pre-crop time period. If it's a legume, it could actually, fix that itself using some of the root structure. Or if it's a grass or like a rye, like I use, absorb some of the nitrogen that was maybe left over from the prior crop in the prior season, and then store that in its plant tissue to be later released when it decomposes, either from termination or from, winter kill due to a frost. So all in all, keeping that live root, we are continuing to cycle nutrients. We can store them, save them for later. And we're then stimulating those microbes that Travis talked about. So different kind of plant, different signals that get sent into the microbiome, all increasing the diversity of life that we have in that soil to later lean on when we plant our cash crop. Okay, next slide. All right, so efficiency of nutrient application. And I'll talk a little bit about, NUE, kind of this nutrient use efficiency is a very hot topic here lately. Really, it's just about getting as many bushels out of every pound of nutrient that you apply, right? Travis alluded to losing some of those from environmental impacts, from tie up. The more nutrients we can actually get into our plant at the end of the day, the more efficient we are with them. So obviously with increased efficiency comes the opportunity to maybe reduce applications or increase yields with what we're already applying. But just some ways to think about, the 4 R's and really kind of to unpack them into strategies that you could use on the farm. Stabilizers are a very easy kind of first step. If you're putting out nitrogen or even some other products, make sure that it's going to be held in a form not susceptible to leaching as long as possible. Some interesting technology coming from the phosphorus side of things as well, just kind of absorb and hold and release when needed. Split apply in, so put that nitrogen on as close to actual plant need as possible. When we think about the nutrient uptake of corn, it's really heavily weighted towards the back half of the season. So the closer we can get to putting it on to need, the less we are exposed to some of those loss factors. Variable rating based on soil samples, kind of mentioned that at the beginning. Don't put nutrients where we don't need them. That increases our opportunity for runoff and negatively impacting the environment. Eliminate those insurance applications of N. This may be the last year of that for a while. I know people had some nitrogen booked, so maybe still happening this fall, but if everybody's paying 4 figures for ammonia next fall, I think we'll probably see this go away. But it's the adage that I don't want to fall short, so I put on a little extra. Those last pounds that we apply, we know are almost always negative for profitability. They're costing us more than they're gaining us. So eliminate those. And then the last is, and kind of a concept that's newer or maybe just not as popular, but focus on uptake. So I think we've gotten really good at taking soil samples, but not looking at what's actually making it into the plant. So full disclosure, that's a tissue sample of mine from this summer. And you can see there are some big time deficiencies as far as nitrogen in the plant at the time of the sample, magnesium, manganese, lots of these different things that rely on soil microbes and soil biology to solubilize and get into that plant. So we can't just pour the coals to it from a fertility perspective. We need to develop strategies to make sure that we're getting it from the soil into the plant. And a lot of that is focused around the microbiome and that soil biology. So, and the last thing there, just picture me out strip tilling on the right. So banding nutrients, specifically around things like phosphorus that are, can be tied up based on unbalanced pH. Get them in a band and get them right into the plant is a good way to increase that nutrient use efficiency. Okay, next slide. Perfect. So, no different than an Olympic athlete or a professional athlete. We can do a lot of strategies, good diet, good exercise, but sometimes we need a little bit extra, something extra to make sure that we can perform at our top potential. And that's really where we think about activating microbes and our product source. So if we've done everything that we can with kind of those previous topics I talked about, or we're just looking for kind of the next level of activity in our microbiome, we can actually stimulate them with our source products. So specifically looking at nitrogen fixing bacteria and phosphate solubilizing microbes, they can be activated with our product source through a foliar application and actually increase their activity. So we know they're there. To what Travis mentioned, sometimes they're just dormant. We got to wake them up. So we have created a molecule that mimics that signal, and we see increases in activity of those specific target microbes and target bacteria with an application of source. So very exciting opportunity for corn as well as soybeans. And to dig into that a little further on the next slide, we'll look at what that can actually mean for you. So I'll start here. There's a lot on this slide, so I'll kind of talk through a few different things. The chart in the background is the MRTN nitrogen chart. So the return to nitrogen applied. And you'll see that line goes up for a while, and then it kind of plateaus, and then we start to go down. So where a lot of producers are currently applying N is on the downward slope of that chart. Myself included, I'm not perfect. I may be close to optimal, but always striving to do better. And what that means is the last pounds of N applied are maybe increasing yield, but they are doing it at a lesser rate than the expense that they incur. So what we see is the opportunity to make an application of source, activate that microbiome, get as many solubilized nutrients, especially N and P, into that crop as possible, and reduce the application of synthetic nitrogen. So we can do this anywhere from 20 to 50 pounds based on where a producer is already starting on this line. And what it gets us is that box on the right, which is very exciting and really where the rubber meets the road, is a gain in nutrient use efficiency. So when we look at a standard rate of nitrogen at 0.86 pounds of N per bushel, so this is already a producer who's fairly lean or doing better than less than one, I say is a guy trending in the right direction. If we add source to that field and reduce 25 pounds of N, we can actually get all the way down to 0.73 pounds of N per bushel, still increase yield over what that baseline was, and have a huge gain in profitability and nitrogen use efficiency specifically. So good news is, there are strategies that we can implement on the farm from practices mechanically. And now we have an option as well here with this product source to really chemically stimulate that microbiome and bring it all together into a more profitable and more sustainable pathway. So with that, the man of the hour here, I'll start a kind of a chat here with Trey. So Trey, some of you maybe jumped on, row crop producer out in Maryland, some awesome ideas and strategies around sustainability. So we'll just kind of have a back and forth here, learn about Trey, what he's doing generally from a sustainable kind of perspective, and then thinking about how source is entering into that equation for him. So I guess first off, Trey, you kind of started telling us where you're from. Maybe just a little history of the farm. How long some of that has been producing crops, and maybe digging in a little bit to what you grow historically, and maybe next year as well.
Yeah, I come from a pretty standard farm background, I would say, very Midwestern style on the East Coast. Dad built the farm. I farm it, and we farmed together for a while. Now I'd say I'm pretty much in charge of it. We grow corn, wheat, and soybeans. Throughout my career, I would say I started getting involved with the environmental community here on the Chesapeake Bay. We've got the Chesapeake Bay Foundation. We've got the River Keepers. And I started out with a great deal of fear in working with any of those folks. We kept our farm doors closed and I was always taught to stay very enclosed in a farm. Don't let people know what you're doing. That's the way you're supposed to farm. And I think that mentality still exists in much of the world today, which I think is what's led to a lot of our problems, is this lack of transparency. But what I found in working with those folks and becoming an environmentalist on top of being a large scale family farm is that there's a lot of collaboration opportunities there. And I would say that by working with those folks, by being on the board of the local river keepers and whatnot, and discussing it with all these people that are very passionate about the environment and our local community, I kind of feel like I've got people helping me. So instead of having animosity towards the large scale grower, which is typical within any community, which I don't think scale is relative. I think it's the mindset of the farmer, whether you're very small or very large. And I think that by having all those folks supporting me, helping me make decisions and helping me look at my farm differently, it's enabled me to really look at the way I farm differently, and then start to really change the way we farm over time and change the way we look at farming. We still grow corn, wheat, and soybeans. We still have a monocrop all summer. That's still the way that I feel like I can do the best job that I can and maintain efficiency. I don't think that's what we'll do in the future. I think that the world's constantly changing, and the way we look at things is constantly changing. So that's kind of been the nature of the farm. We have a great team of folks that work with us. We employ, about a dozen folks that help me farm, and that's kind of where we are today.
Perfect. Appreciate that. So I'll start off with a hard one. It'll get easier. So sustainability, right? It's a big word, many definitions. I think if you, Travis, and I all wrote our definition on a piece of paper, you wouldn't even think we're talking about the same word. But sustainability, what does that mean to you?
I give this a lot of thought. I looked it up, and the definition of sustainability, according to Google, is able to be maintained. So over the years, I've always said that I'm a sustainable grower. So 15 years ago, I talked to people and be like, sure, we're sustainable. We're doing everything right. We're doing, we chisel plow, but we don't plow anymore in the fall. We're doing split rates of nitrogen. And essentially it looked completely different than it does now. So I look back and I go, was that maintainable? And the answer is no. What I didn't know, while I thought it was able to be maintained, there were so many things that I didn't know. And there's still so many things I don't know that I think that the word sustainable is actually awful. To me, it seems very linear and it seems very static. So I've chosen to kind of interpret sustainability to myself, which is one's willingness to try to improve the world. So I think that gives me more flexibility in my mindset and philosophy and psychological way I look at the farm to be constantly evolving. I think sustainability is often looked at. I know here in my region, when we worked with the Chesapeake Bay Foundation, we started doing cover crops and we did these things. We always felt like there was going to be a finish line. You know, if you're running a race, here's the line. Once we hit this point, we're done. That's the way we'll maintain farming for the rest of our lives. Well, that's not true. Farming is constantly changing. The world's constantly changing. And I think to me as a farmer, I feel like I need to be constantly changing. So I think there needs to be a little bit more of a philosophy behind it and a little less linear thinking, which makes most people want to throw up to think about it that way, right? We like a straightforward thought process, but I think that we need to start to add a lot of flexibility to it. I don't know what the right word is, and I know we would all disagree on it, but every farmer farms differently. So I think we need to look at it more as an art form and see, are people giving, if you look at the definition of, say, poetry, I was trying to think of another word that would kind of institute the ability to be creative within growing food, because we don't like to embrace creativity, I don't think. So if you look at poetry as a definition, which has lots of different forms where people agree it's all poetry, there's good and there's bad, and there's better and there's worse, but it's global, it's a community, and everyone can enjoy it. And everyone's seeking to improve, but it's an intensity given to the expression of feeling and ideas. So I think that actually kind of pertains to farming, right? Particularly as we look at regenerative. There's people that in regenerative that don't think what I do is regenerative, and I'm happy with that, right? I use chemicals on large scale, I use a lot of technology, and I have folks that will argue with me about whether or not it is, but I'm going, why don't we learn from one another? Why don't we make it this expression of the way we grow food, interpret it differently, and then figure out which one's better or worse, or which ones complement one another and which ones substitute each other. So I think thinking about all these things a little differently, for me, has helped me be adaptable and adoptable to new practices. So if you look at my slide, I think should be the next picture. This is how we plant most of our fields. So this is us planting soybeans. And I would have thought 10 years ago, this is not possible, or it doesn't make any sense. And now we're growing really high yielding soybeans. We're getting great nutrient retention through the cover crops that you were talking about, Jeff. Mine are just a little bit bigger than yours. They're flowering. And I think that being able to think about things more of an ecological system and bridging these things together and finding some more balances, which works and sometimes doesn't, really has helped me look at agronomy and soil and the science of farming much differently. So I've taken it from kind of gone from pure science through my education into more of a philosophy, but then that's bringing me back into science, but looking at it completely differently.
Yeah, that's great. That's great. So kind of on the topic of some of these practices here, you're showing us kind of planting green into this cover. What are some, regenerative practices that you've adopted over the years? And then maybe what are a couple that you have on the docket to implement here in the future?
Well, this is my main one. I mean, we started planting green probably 12 or 14 years ago, which planting green simply means planting into a field that's still green. And we always thought that planting into a field that was brown, whether it was no-till or conventional, was better because it looked much more stable. It looked more linear. And we thought that the proper seed bed should be this stagnant, sterile environment. And what we're finding is that a dynamic environment where there's living root systems is actually much more stable and monolithic to the seed and the way it sprouts and comes up than it is while it's growing. So if you dig down into the ground, this ground where all these cover crops are growing is actually more consistent than a field that's no-till that's been burned off, which is crazy because it should be the opposite. Because when you look at this field, it looks wild and crazy, but when you start digging into the roots and you start looking at the soil, it's much more consistent. And I think the seeds are nurtured more. So I think that this starts to, is where our big difference has been. So we're just trying to master this. We're starting to put in different cover crops that have different flowers. So we get different stages of flowering. As we see climate change, I think as the temperature changes, but daylight does not, a decent amount of nature is going to become out of sync. I also think that we don't have as many flowering plants around our houses, around the forests and everywhere else, that I think that farmers are going to need to provide ecosystems. We're going to need to provide ecosystem services within our fields to help adapt to climate change. So this is what we're doing. We're doing a lot more mixes. We're planting a lot more legumes. Our standard mix is about 7 or 8 different seeds. So we've got rapeseed and turnips and kale, vetch and clover and all these different things to try to get that ground really dynamic. So when we go to plant, we're planting into this diverse environment. We've tried roller crimping. We're trying to alleviate, one of the things we're doing moving forward is trying to reduce our reliance on chemicals. We're still using weed killers. I've tried roller crimping and getting weed control, and I'm getting better weed control. I'm definitely seeing things that are better, but I can't get it perfected. I haven't quite figured it out. I think it's possible. I just haven't done it yet. We're reducing our insecticides quite a bit. We don't spray anything over the top anymore. We're still using an in-ground insecticide because of grubs. So kind of trying to figure that out, if there's a natural, something that will eat the grubs or a way we can eliminate those later. So those are nutrient efficiency. Of course, Jeff, you covered that, but that's definitely a big part of what we're doing. We've been doing some test plots, and I'm thinking that with the new technology, sound being definitely one of the big ones, that we're going to reduce nitrogen hopefully by 15 or 20%. And given the pricing this year, we're definitely going to take some more risks. We've gone from 23 cents a pound to about 80 cents a pound. So, the economics have changed dramatically.
Absolutely. So you mentioned sound and the product source there. How have you fit source in with some of these practices, that you've already been implementing over the past, and how do you think going forward? You mentioned nitrogen reduction there. Just kind of how have you entered sound in and source specifically into your strategy?
I'd say same as you. My soil is a whole different color than yours, Jeff. Yours is nice and black. It's the prairie soil. It's the fertile crescent of the world. All these great things. My soil is Appalachian loess, meaning it blew in from the Appalachian Mountains thousands of years ago. So you're definitely in a much better spot. So our mineralization rates and the ability for our soils to hold fertilizer is much different than yours. It's greatly reduced. So what we've done is we've always done the split applications of nitrogen like you referred to. So we do some with the planter, we do a little bit up front, and we put the bulk of it on while the corn is growing. We also use a lot of chicken manure. So that's kind of a slow release fertilizer. And what we're really hoping to do is the fact that we can put the source on when the corn's about to tassel, which is when it needs nitrogen, which is when our thin soils are typically running out of nitrogen. We're getting bigger rainfall events. So the way we handled nitrogen before is not as sustainable as it is today. So I think that adding that 15 or 20 pounds when the crop needs it is kind of the perfect fit for us. We're using a couple other products. I don't like you talked about the nitrogen stabilizers. I'm not a big fan of those. I don't know that they're healthy for soil health. So we can agree to this. Hopefully we don't agree on everything, right? That would be bad.
Yeah.
That would mean we're not thinking. But so I think that source is definitely for me, is an excellent fit, particularly where I don't have high mineralization in my soils. We're having larger rainfall events, and we're having hotter, drier summers here in Maryland due to climate change. So I think that being able to put this on and have the plants adapt to that when they need it, hopefully is going to be a huge benefit for us.
Yeah, absolutely. So maybe kind of last question here, and then we'll go into kind of open Q&A with the group. I've got a few questions lining up here. But what would you recommend as kind of a first step into this kind of sustainable path that you're on, probably further along than me, I'm on? Even though we have very different farms and different soil, everybody's competing for something else, right? Where us, it's all like just competition on margin, right? No matter where you're at. So what's like kind of a first step to get started, and then just kind of open-endedly, any thoughts you have around, sustainability and how we can think of that, as a strategy going forward?
Well, to me, the struggle we always had was getting parity in yields between conventional tillage and no-till. And I don't think that no-till works very well if you don't have the presence of cover crops. Compaction is compounded. The soil becomes much more diverse, where you have root systems from the last year's crop, where you don't in between the rows. It's very difficult to get that parity of yields. If you institute the cover crops, it makes parity on yield possible. The problem is it's so crazy to plan into. It's like a different profession. Like I still have farmers that have seen me doing this for a decade and they drive by and they still think I'm nuts. The guys that work with me, I've got some young guys, they still get hazed by the other young guys. I just, I've kind of gotten to where I'm too old and I zone it out and too grumpy. No one fools with me, but they're like, are you sure this will work? I'm like, well, we've been doing it for 10 years. But I think that doing it that first time really in a crazy way, as long as you have a plan, is the way to go, because that's the only way you're going to get comfortable with it. And I think planning, for me, it's planning a GMO. That way you can always clean it up. It goes against some of the conventional thought processes of sustainability and stuff. But if you plant like a dicamba Roundup ready bean and you don't get your cover crop killed, anything can kill it, right? I mean, it's easy to clean up. So like the fields where I've tried the roller crimping and it didn't work and the weeds came up through it, I could go in and clean it up. So I'm not saying that you have to do GMOs. I mean, this isn't a commentary on that, but just make it easy for yourself to be able to go in and clean it up. And that to me is what it takes. And then once you see the stuff coming up through it and you see how pretty the fields are, I mean, walking through these yellow flowers, I walk in my fields in the spring, like at planting, and there's pollen in the air. It smells like flowers. You're walking on the ground, it's spongy, it's green, it's, the stems are snapping, the bees are buzzing, the birds are chirping, and it's just an entirely different experience that just is exceptionally, to me, rewarding.
Absolutely. Sounds like poetry. You tied it all together there at the end with that last sentence.
That's what I tried. It is though. If I hadn't experienced it, I would never come to those conclusions. It wasn't because I'm that by nature. By nature, I'm a scientist, an agronomist, an economist. But once you start experiencing all these things, it's like hiking in the mountains. Like you don't go into, you might go in the mountains to get exercise, but by the time you're done, you're in wonder. And I never thought that it would be possible. And having seen it over the last decade or two, it's really been a nice experience. And then now that we're achieving yield parity, we've got efficiency parity. I think we've got superior profitability over where we would be if we were doing a lot of tillage. But I'm also getting ecological services, and I'm proud to tell my kids the way we farm.
Perfect. All right, thanks, Trey. So we'll kind of move into questions now. I see a few, Travis. I'm not sure if you have you've kind of had your eye on that, if you want to prioritize some over others.
Yeah, I've been checking out the chat. There's a couple here. I guess first one, Jeff, is for you. It's how are regenerative practices you mentioned complemented by source? And so maybe I can even make it a little bit more specific. Do you see any interaction between, say, no-till environments and source? Does it work better or worse than conventional till? Anything like that you've seen?
Yeah, it's a great question. So yeah, actually what we've seen, so since, source is a product that's really activating the microbes that are present in there. So we're taking, 100% and making it 120%. The more we start with, we have actually seen trends of better responses for source specifically. So in some of those environments, no-till, strip-till, even cover crops, the more diversity of microbes we start with, the more there is to stimulate. So yes, we've actually seen kind of a doubling down of the benefit of these practices and source.
Awesome. I'm going to sort of skip around here, and this one might be for more for Trey, but Jeff, you jump into a question about any mention of rotations and grazing livestock. What's the view of the source team here?
I guess not grazing specifically, but just in terms of livestock, I'll jump back to silage for a minute because we did some nice studies there. Active soil biology comes through all the way to feedstocks and nutrient content. So with source applied on corn for silage, this isn't really grazing, but just the feed end use case here, we actually saw increases in net energy, increases in protein, increases in tonnage. So really making a more sustainable food source through silage. We're also going to start some work on alfalfa and potentially some other feedstuffs. But yeah, we've seen higher nutrient concentration contribute to a higher quality ration. Can we unmute Trey?
Oh, no, I'm good. I didn't really have
Okay.
anything to add to that, Jeff. I thought you did a nice job. Sorry.
Okay, perfect. I did see one yeah, back at the beginning, kind of, there was a question about just N and P. I'll just quickly mention, I think you answered that maybe in the chat, Travis, but we do see, and this kind of goes back to that Liebig's law of the minimum I brought forward, kind of when you balance a nutrient or balance the system, it seems to bring out access to other nutrients. So yeah, we actually did a pretty robust set of tissue samples this year. So while some of the primary activities on N and P, we saw increases in lots of micronutrients. We saw improvements in soil structure and rooting depth. If you think of immobile nutrients, like even potassium, if we can feed the right amount of N and P early and get better root depth and better root access, we can touch some of those nutrients that are otherwise immobile and access them. So kind of bringing that whole system together and equalizing it really gives us the opportunity to uptake a little bit of everything and not just, more N and P.
Absolutely. See one on here. How does source compare to a biological? Is it a biological? So looks like Rich from our team answered this in chat, but I'll just kind of expound on that. So, there's a lot of groups out there that are basically trying to either engineer or develop microbes that you then add to your field. So that's pretty exciting work and something we follow pretty closely. Our approach is pretty different. What we're trying to do is work with what's already there. And we're trying to really leverage the natural biodiversity of the microbes in the field, because what we see when we go out and we do soil sampling and soil sequencing is that there's a lot of diversity there that's really untapped, that's really has these abilities to solubilize phosphorus and fix nitrogen, but it's just not turned on. So our approach is really to take what's there, flip it on, signal to it, turn it on with these natural product mimics, these signals, whereas the biologicals players are really more about adding a living microbe to that system. So different approach, could potentially be complementary to each other, but really we're trying to leverage what's there, while the others in biological space are trying to add something to the system.
Perfect. I'm gonna go back to one. Lynn had a really great comment on NUE. So just thinking about like applied N divided by yield minus yield of 0 applied N. And you're exactly right. I mean, soil has the ability to sustain yield in crops very well. So we see this even in, when we do studies with different nitrogen rates with and without source. Typically of those nitrogen rates, the lowest nitrogen rate is the most profitable. And that's kind of why I wanted to bring up that MRTN curve of everybody being so far on the right. Typically in those trials, we'll see a profitability improvement by taking out N, even like without our product, right? And I think that's that mindset of insurance nitrogen that everybody has gotten to over the years. So yeah, I totally agree with you. When you look at the nutrient use efficiency and then subtract out the yield potential without fertilizer, it makes it really ugly, right? It's probably like 2 or 3 pounds of N applied per bushel achieved when you look at what that soil can sustain itself through mineralization and just other natural nitrogen sources. So it's a great point. And all the more reason to have an active microbiome and rhizosphere to contribute as much of that free nitrogen as possible. So.
All right, looks like we have time for maybe 1 or 2 more. One question here. Have we done any field trials with source on non-crop uses such as restoration vegetation establishment?
Yeah, not a ton. We're continuing to explore that at many different applications, right? So no, not specifically some of those non-crop uses. We started here and we'll broaden the base from there. So that's the fun stuff Travis gets to play with in the lab and beyond.
Yeah, our strategy has really been start with corn, soy, given the sort of massive fertilizer applications on corn and the importance of soy in that rotation. And then we have sort of a pipeline that's looking at wheat, cotton, canola, sort of moving down the row crop list. So non-crop uses are pretty fascinating to us for a lot of reasons. So that is in the pipeline just a little bit further back.
All right. That looks like it covers a lot of these questions. I don't know if Sarah, if there's anything else that we need to touch on.
Nope, I don't think so. Unless you guys have any closing remarks to share with the audience before we wrap things up.
Yeah, just wanted to say thanks everyone for joining and the good discussion and questions here. Enjoyed sharing our perspective with you.
Yeah, and big thanks to you three. Sorry, I didn't give Trey and Jeff a chance to say goodbye or have any closing thoughts, anything to share.
I'll just echo Travis's appreciation for your attendance and thanks for sticking with us.
I'll stick with the same. Thank you all.
No final thoughts on poetry, Trey. I loved that that comparison too. So thank you. And thank all of you for joining us. What a great conversation and a really interesting technology you guys are working on. Thanks for making this possible. If you guys want to learn more about Sound Ag, you can reach them online at sound.ag. And on behalf of the Regenerative Food Systems Investment Team, we thank you all for attending and participating today. And we invite you to continue to engage with our community through our events, newsletter, webinars, and directory. And again, you can learn more about us at rfsi-forum.com. I would love to say have a wonderful rest of your day to everyone. We will stay online here just for another minute or so in case there are any more questions that you didn't get in, and have a wonderful day. Thank you.